Welcome to Module 2 of CS 179, Networking 1. And we're once again using the book by Mike Myers, Managing and Troubleshooting Networks from McGraw-Hill. Today we're going to talk about cabling and topology based on Chapter 3. And the different categories are going to be different ways to set up your physical network, such as the bus, ring, star, hybrid, and mesh. And also we're going to talk about the different kind of cables you can use and what their capabilities are. So here we have another one of our LAN setups, similar to the one we had in Module 1, except for we also have added an access point. So we've got our client computer, we've got our network server, all connected to a switch, as well as our access point, and we have got our client computers connecting wirelessly to the access point. So a little different than the last one because we added wireless into it. So what's the topology that we're going to talk about here? Well, multiple different ones. Topology basically is the basic geometric layout of the network. It's the way the computers connect to each other. So there's advantages and disadvantages to every different type of topology, which is why you should be aware of all of them, and so you can decide which one is the best for your situation. So the logical topology is how the network works conceptually. It's like a logical data flow diagram. And the physical topology is how the network is physically connected, like the physical DFD or physical ERD, which we'll talk about in a minute. So shared Ethernet's logical topology. So shared Ethernet is logically set up as a bus. All messages from any computer flow onto the central cable bus. A computer receives messages from all other computers, whether the message is intended for it or not. So it's not necessarily the most secure way to go. When a frame is received by a computer, the first task is to read the frame's destination address to see if the message is meant for them or not. So here's what a bus topology looks like, this top one right here. So basically you have one long cable with terminations at each end. There's no switch involved. And your computers are all connected to this line. Now this was more popular back in the 90s more than it is today. I don't really see any new networks set up with this bus technology. And mostly it's because it was used with cable rather than with Cat5 type cords. So, and also there's no central location where they're all connected. So if there's a break in the line, it actually breaks it for everyone. And that also includes if the terminators at the end of each line breaks, then you've broken that connection for everybody. Everybody can possibly see the messages sent from everyone else, so it's just not a good way to go. The star topology is definitely the most popular one today, and you have your hub or switch in the middle, and then all your other computers are connected to it. So there's also a multiple hub Ethernet design. Now when I say hub, you could also use switches in this particular context. So you've got your hub in one spot where you have all your devices in that area. Say maybe this is a different floor for some reason. And you've got another hub on another floor and you've got them all connected. Well, one cable can go connected between those two hubs. So the nice thing about this is it's very easy to set up, but the bad thing about it is that you lose a lot of your high-speed connectivity. So if all of these computers are trying to connect with just this one computer here at the same time, they're going to have to share the bandwidth from this one cable. So although it's easy, it does limit your speed. And you also could run into problems where if one hub goes down, you may not realize it for a long time because the other hub is still up, and so making troubleshooting might make it a little bit difficult. So in switched Ethernet topology, where we've moved from hubs to switches, users can have workgroup switches designed to support a small set of computers. It looks similar to a hub, but very different on the inside. It's designed to support a group of point-to-point circuits, no sharing of circuits. So you don't have to worry about anybody seeing the broadcast traffic of anybody else's traffic as they're sending data packets along the network. The logical and physical topology of the network becomes a star topology because of that switch that's right in the middle. The switch reads destination address of the frame, and only sends it to the corresponding port. So that's the difference between hubs and switches. Switches actually will send a point-to-point connection between the two computers trying to communicate. It won't broadcast all that information, and it remembers where the computers are on both sides. So next time you want to communicate, you don't have to broadcast to find it. So that memory allows for less broadcast storms. Forwarding tables, they are similar to routing tables, which we'll talk about in a future module. Lists the Ethernet address of computers connected to each port. This is how the different switches can communicate with the different computers. So when a frame is received, the switch reads it at layer 2, whereas the hub was at layer 1. The switch is at layer 2. Reads that layer 2 link layer destination and sends the frame out of the corresponding port in its forwarding table. So here's another star topology, and we've got our layer 2 switch. So instead of hubs, we're now seeing switches. Each one of these computers is plugged into its own port, and each one of those ports can use its computer on the inside to match it up to the computer on the outside, and it does that using the physical MAC address that's on the network card. So every network interface card, or NIC, has a hardware address called MAC, the MAC address. And that address, hardwired into there, won't be changed. And so when computer C wants to communicate with the server, for instance, it records that information, so the next time computer C wants to communicate, it will remember it, and it'll get there a lot faster. All right, a mesh network is a little bit different. It's a very expensive type of a network. I don't see this being implemented anymore, but it's on a lot of tests, so that's why you should be aware of it. So basically, every computer is connected to every other computer. So if one connection goes down, for instance, if this connection goes down, you can still get to all the other computers. There is no hub or switch in the middle. It's just they're all meshed together. There's multiple connections on every single card, and those are connected to every other computer. Not efficient in any way. Yes, it is redundant. That's its positive, but the negatives are so huge. There's just no reason to have that kind of expense, and no one is really making the network cards that have that many ports on them where you can communicate with a large office anyway. A hybrid network could take advantage of the different networks that you may have in an office or multiple offices. So you might be on a bus, you might be on a star, you might be in various different types of networks, but you communicate with one connection going to those other networks, and that allows it to be a hybrid. So a bus can communicate with a star in this particular case. Again, not very well used. Point-to-point network. This is a network where if you have more than one office location, for instance, let's say you're in Portland and your branch office is in Seattle. Well, you could communicate using a shared network, such as you have your ISP, they have their ISP, and then you have a frame relay between them. Or you could go with a private connection, which we call a point-to-point network. So nobody else shares this data. You don't have to worry about anybody else eating up any of the bandwidth or possibly listening in on your communication. There is a point-to-point connection between the two that is always on. So the advantage is, of course, it's very secure. It can be very fast, but it's also very expensive because any kind of private connection is going to cost a lot more to set up and maintain. Point-to-multipoint is very similar point-to-point, but it uses, in this case, a frame relay cloud. Now, you can have a private cloud or a public cloud. In this case, a point-to-multipoint network is going to be a private cloud. So if you have many offices, more than just Portland and Seattle, say you've got San Francisco and LA and Chicago and New York, you can have a point-to-multipoint, which is, again, it's a private cloud using the frame relay technology, and nobody else can listen in on it. Now, the shared frame relay is a public cloud, and that public cloud is potentially, could be have security issues where man-in-the-middle attacks could happen. But they're not very likely, but they certainly could happen. But in a point-to-multipoint, you're not going to have that issue. Network segmentation. So a lot of different offices use segmentation, and they do that either by putting a router between the two groups of computers, or they create what's called a VLAN, or virtual local area network, and you can do that in the switch itself. So in this case, we've got on the left-hand side, before network segmentation, you see everybody's on the same network, and that's not necessarily a bad thing, but if you have too many computers and all of a sudden you have problems with broadcast storms because of network cards that are going bad, or you have security issues where one department needs to be more secure than other departments, then you want to segment those networks so they can't all communicate with each other. And you can do that by putting a server and turning it into a router, or putting an actual router between the two, or putting a switch that will segment them with what's called a layer 3 switch that has routing capabilities that can separate the two networks. So you can allow the communication between the two, or you can disallow the communication. It's up to you. Let's switch over to cable types. You have coaxial cable, or coax, a lot of people call it. It can travel for a while. Well, we had a little bit of a miscommunication on that one. So now we have the coaxial cable. It can travel over medium distances. It is not a twisted pair. That is a quiz alert, so be aware of that. And no longer used as a network interface card type of cable, but is used by cable companies to connect cable to your office via the various different telephone poles, and they can also bury them underground. And they'll do this in order to get you high-speed internet using it for broadband. So what used to happen back in the bus network days is we used to use coax to actually connect our network cards together, but it just wasn't efficient, so we don't do that anymore. All right, let's talk about twisted pair. And there's a few different kinds. There's shielded and there's unshielded. Of course, shielded costs more because it will not be affected by electromagnetic interference as much, so they have to wrap it with additional foils and things like that. Unshielded is a lot cheaper, but of course you have to worry about EMIs in case you have any of those kinds of issues. Keep them away from magnets and electrical wires, things like that. And then you have plenum rated. Now, plenum rated could be shielded or unshielded. It's basically they change the plastic in here to, in case it catches fire, that it doesn't give off fumes that could kill people. So this is definitely required in buildings where there's multiple floors, where people have a harder time getting out of a building that may be on fire, and so they don't want people to die from the inhalation of these noxious fumes. So that's why you have plenum rated type cables. Let's talk about fiber. Great thing about fiber is it can travel for a long way, miles and miles. It's not susceptible to interference, so if you have any kind of electrical storms or power lines or anything like that, it will not affect fiber. It basically just transmits pulses of light. That's how it gets there, and gets converted from those pulses into Ethernet and various other different protocols on the other end. There are lots of other different types of cables, of course, that you can use to transmit connectivity between computers. There are the serial cables. There's a serial cable right here. They typically have 9 pins on them. There's parallel cables. Those typically have 15 pins on them and communicate with printers. Firewire. There's Firewire over Ethernet and USB over Ethernet that allows you to convert a Firewire or USB card into an Ethernet card. So if you run out of ports on your computer, for instance, you can plug in one of these into your devices and use an adapter and then turn that into a network card. So to summarize, we talked about network topology, such as the bus ring mesh, and we talked about segmenting different networks, and we also talked about cabling types. So stay tuned for Module 3, and thanks again for joining.